Hello everyone, I am Sandeep. I am here to discuss about Karatsuba algorithm. Given two binary strings that represent value of two integer, find find the product of two strings. For example, if the first bit string is 1100 and the second string is 1010, output should be 120. For simplicity, let the length of the two strings be the same and be n. A naive approach is to follow the process we study in school. One by one, take all the bits of the second number and multiply it with all the bits of the first number. Finally, add the multiplication. This algorithm takes time complexity of O of n square time. Using divide and conquer, we can multiply two integers in less than time complexity. We divide the given number in two halves. Let the given number be x and y. For simplicity, let us assume that n is even. The product xy can be written as follows. We can take a look at the above formula. There were four multiplication of size n by 2. So we basically divide the problem of size n into four subproblems of size n by 2, but that doesn't help because the solution of the recurrence t of n equals to 4t by n half plus O of n is O of n square. The tricky part that of this algorithm is to change the middle two terms to some other form so that only one extra multiplication would be sufficient. The following is tricky expression for middle two terms. So the final value of xy becomes, as shown below, with about it the recurrence becomes t of n is equal to 3t of n by 2 plus O of n, and the solution of this recurrence is O of n power 1.59. What if the length of the input strings are different and are not even? To handle the different length case, we append zeros in the beginning. To handle odd length, we put floor of n by 2 bits in the left half and cell n by 2 bits in the right half. So the expression of xy changes to the following. The algorithm is called Karatsuba algorithm and it can be used for any base. The following is the C++ implementation of the above algorithm. And the output of the problem is shown below. The time complexity of the above solution is O of n power log base to 3 equal to O of n power 1.59. The time complexity of multiplication can be further improved using another divide and conquer algorithm, fast Fourier transform. We will soon be discussing Fourier transform as a separate course. The Karatsuba algorithm is a recursive algorithm since it calls smaller instances of itself during execution. According to the algorithm, it calls itself only thrice of n by 2 digits number. In order to achieve the final product of the two n-digit numbers, now if t of n represents the number of digit multiplications required by performing the multiplication, t of n equal to 3t by n by 2. The equation is simple recurrence relation which can be solved as apply t of n by 2 equal to 3t of n by 4 in the equation we get the following. Recurrence relations can be solved using Master's algorithm. Since we have a dividing function in the form of the given, since f of n represents work done outside the recursions, which are addition and subtraction arithmetic operation in Karatsuba, these arithmetic operations do not contribute to the complexity. Check the relation between a and b power k. It is shown below. According to the Marshall theorem, apply case 1. You get t of n equal to O of n log 3. The time complexity of Karatsuba algorithm for partial multiplication is O of n power log of 3.